Alrighty. Well, there's a couple more people that have joined, so we're going to go ahead and get started. This session is being recorded. And we are going to post it for everyone later so y'all can see it and share it for whoever wasn't able to attend today. But on behalf of Arizona State University and the Ira A Fulton Schools of Engineering, we'd just like to welcome you to our session today. My name is Kaylee Graham. I'm staff here in the Fulton Schools of Engineering with our outreach and recruitment team. With me of our director, Mike McBride, and then our Desert Wave Robotics team and their faculty. We're going to turn it over to them to let them share who they are and all the really amazing things they get to do. During this session today, we really encourage you to participate by putting questions into the Q&A tool, and we will have a lot of time for Q&A after they kind of talk about who they are and what they do. We will start fielding questions. You'll notice that the chat is turned off and we cannot hear or see you, but again, you can participate using the chat with us today. And it looks like there's already a comment in our Q&A. They're really excited to get to see the celebrities on this webinar. Our students are really awesome. And I know they're excited to share their story with you today. So with that, I'm gonna let Andrea take over. If you want to go ahead and introduce yourselves, and Mike and I will be back to just moderate for you.
Sure, thank you. We have prepared a presentation for you all. Okay, I just want to verify you can see the screen, correct? Okay.
Yes, you are good to go.
Thank you very much. Okay, well, hello everyone. We are so excited to share our story with you today. We are Desert Wave, an underwater robotics team here at Arizona State University. Our team's in partnership with the Cecil Pwede Foundation. It's a nonprofit based out of the Chandler, Arizona area. And what we do is we build robots to compete at an international competition, but we'll talk a little bit more about that later in our presentation. Please let me introduce our team here with us today. My name is Andrea. I am studying software engineering here at Arizona State, and I'm also the team's project manager.
Hi, my name is Skylin. I'm studying robotics engineering, and I am the program lead for Desert Wave.
And then hello, my name is Dr. Frank, and I am the faculty advisor for Desert Wave, and I also teach at the Polytechnic campus at ASU.
Thank you. Yeah, so today what we're going to do, we're going to discuss the field of autonomy in robotics. We're going to explain what that is, why in the world we care about this topic, and how our team uses our project to explore the technologies that make autonomous systems possible. I do want to make a note that throughout this presentation, we're going to refer to our robot as either the robot, a submarine, an underwater vehicle, or an AUV, but just take note that they all refer to the same type of machine. Now, before we continue on through our presentation, we'd like to take some time to talk about the concept of autonomy. Now, autonomy refers to describe how capable a machine is able to do things on its own. And for our purposes, we will refer to autonomy to describe the systems that we develop for our robots to be able to perform certain tasks all by itself. Now, as you can see in this picture here, we have shown 3 different versions of the same robotic suit as they appear across this scale. Now, if you've ever seen the movie Iron Man, you may recognize these suits. And if you haven't seen the movies, I'll explain. These characters, the main character creates a robotic suit to help him do different things. Now, the first suit that you can see here on the right, or on the left, I'm sorry, is able to help the main character do things such as like fly and help him to be stronger. But there really isn't any element to the suit that makes it intelligent, which means that the creator has to make all of the decisions while he is wearing the suit. And then later on in the story, if you look to this middle photo, the main character creates another suit that is more intelligent than the first one because he's added an AI software that is able to feed information to him while he's wearing the suit. Now, in this version, the main character now has a computer that's able to help him make decisions. And then eventually, as the story continues on, there's a more final version of this robotic suit that would be said to be the most autonomous, which means that this suit is the most intelligent. In fact, it's so intelligent that it doesn't really need even the main character to be able to do things. And really, that's the idea behind autonomous technologies. It's the idea that we can engineer inanimate objects, such as robots, to be more intelligent and capable of doing things all on its own. So now if you take this, the leftmost suit and compare it to the rightmost suit here, we could describe both of these robotic suits to be of some level of autonomy, but they are across the spectrum to describe that, or just to represent that they're not capable of doing the same things on its own. Now, this begs the question, how do we give robots autonomy? Well, first, what we can do to answer that question is we can really look to ourselves to explore the ways in which we have autonomy. So you and I, your teammates, we have autonomy because we have a brain to make decisions. We also have eyes to help us see and ears to hear. Now, what we do is we're able to take the knowledge that we have about ourselves, and we can take what we know about the systems in which that give us the capability to govern our own decisions and help us to do actions and give us capabilities on our own. And we can look to explore other technologies that exist or that will need to be developed in a way to help robots mimic these same types of functions.
Well, if we want our robot to make these decisions, we have to give it a brain, like shown on the right side of the screen. A robot uses a computer for its brain. The cerebellum is also a part of our brain that helps us with posture and balance, just like a gyroscope would help a robot in the water balance. So what if we wanted to give the robot a gift of sight? We can do that possibly with cameras that are attached to the robot to see into the ocean. And just like we can hear sounds with our ears, a hydrophone shown on the right side of the screen can help robots hear sounds in the water. So those are only some of the tools we use to give our submarine autonomy. But the main point here is that we can use some sensors to help robots mimic human senses. Our sub is known as an AUV, which is an acronym for an autonomous underwater vehicle. That means that our robot is like a sub and is used in the water, not in the air or on the ground. So when we put our robot into the water, we actually activate her program and she is able to navigate through the water by herself with us having a controller. Now, why do we care about underwater autonomy technology? Why does the world care? And why do we want to perfect it? So people who are interested in these systems are rescue professionals, military, environmental conservationists, and explorers. So has anyone ever told you that the ocean is mostly unexplored? This is because exploring the ocean can be very dangerous to humans. We need special training and equipment in order to spend a long time underwater. The deeper you go, the more intense the pressure gets, the darker it gets because sunlight cannot pass through, and communication becomes to get harder the deeper you go. Luckily, we can use machines like AUVs to do a lot of the exploring for us, which makes it safer for humans. And then during the Q&A session, we would love to hear from you what percentage you think of the ocean has actually been discovered. Okay, so in this video, you're gonna see our AUV Phoenix at the 2019 RoboSub competition. So what does our team do with AUV? We actually work on it all year long and then take it to this competition, the RoboSub, where many teams across the globe compete against each other, showing off ideas and designs. As you can see in this video, we have dropped the submarine into the pool where there is an obstacle course filled with different tasks that our robot has to accomplish all on its own. What is really cool about these tasks is they were designed to mimic different problems that exist in the real world today. These problems may include such tasks as picking up an object, dropping an object off at a specific location, navigating through an unknown area, shooting a projectile at a target like a torpedo, and identifying certain objects in the water and making decisions to perform different tasks like the AUV is doing right now locating an object in the water.
Yeah, and so to continue further, we'd like to introduce you to one of our most important team members, our AUV Dragon. Let's talk about some of the things that she is capable of doing and how we help her to accomplish the tasks, kind of like the ones that you've just watched in the video that Sky shared. Now, when the competition season starts, we look to the different tasks that we would like to give Dragon the ability to complete. And so through some of these mechanisms that team members have designed on our team, we are able to give Dragon the ability to drop objects, to grab objects, or to shoot them. So here we have like a marker dropper. We have our torpedo launcher that one of our team members designed, which will shoot a small torpedo at a target. And we also have a grabber claw mechanism to pick things up. And when we design a new part for a robot, we actually go through a pretty similar process to what you might have experienced or learned about in your school or on your team projects. Before we have our official design ready to go for our submarine, we first have to brainstorm the way in which we would like to solve the problem at hand. And that starts after brainstorming, that starts with us finding objects within our environment that we can create a prototype with. Like this image here, you can see we've used a simple paper towel roll and pencils to prototype this marker dropper mechanism. And once we've created a prototype, all before manufacturing, we would like to come up with a version that's ready for testing. And so once we've designed these parts, we can then use 3D printing to manufacture those pieces. But as I said before we put the actual mechanism onto the submarine, we have to test it out. And an example of this testing is depicted in this picture here. So you can see that we are testing the torpedo launcher mechanism in the pool, in a bathtub. And something that we're doing here, we're testing the mechanism itself, but we're also testing the torpedo because the torpedo is also 3D printed. And if you can just watch very carefully, as soon as the torpedo is released from the launching mechanism, it rises to the surface or floats very quickly as soon as it's released. And for us and our purposes, that's actually a problem because we don't want the torpedo to float to the top as soon as it's released. We'd like for it to travel in a more straight path so that it will glide through the water and reach the target that it's destined to hit. So, so after that testing, you can see there's been some improvement in the development. And in this bottom picture, as soon as the mechanism is released, the torpedo travels in a more straight path beneath the surface, which is more, this reaches the goal that we're looking for. And all through testing, we're able to learn that if we make simple modifications, such as just printing it in a way that makes the torpedo heavier, then we can come closer to a final design that will accomplish the goals that we're looking to reach.
So although our main focus is our technical project, Desert Wave is much more than that. We are role models for our community. We work with our little sister team, Degrees of Freedom, a high school robotics team in the Chandler area. As you can see in this slide, we have game nights, virtual game nights, where we come together and we discuss our successes and we love to share our stories with each other to tell about our day. So here is a link to a game developed by Dr. Frank called Mission Phoenix. We encourage you to test it out in your own time and explore how you can increase the capabilities of autonomous vehicles by adding sensors. The game is a great example of how we can use autonomous systems to make a human job easier. And we want to say thank you so much for attending our presentation today. We will now open the floor for any questions you may have. Thank you.
Awesome. So I think you guys had thrown out a question about how much of the ocean was unexplored. That was your question. So I see there was someone had put in they thought maybe 5%. I don't know if anybody else wanted to add what they might have thought in there, and then we can let you guys want to answer that and talk about that a little bit. I see. Oh, this is a different question. So I saw 5% was the question that was left unexplored. 1%. What's the answer? How? Oh, that's not it. Andrea, Skylin, do you want to answer?
Yeah, definitely. So it is 5% of the ocean that has been explored. It's pretty crazy, but the reason why AUVs are so important, we really want to increase that percentage, and we want to learn as much of our ocean as we can. So that is the purpose of kind of bettering these AUVs and just getting as much information about the ocean as we can.
So here's a question. How deep can your robots go?
That's an interesting question. So I would say that we haven't put our robot to the fullest test of depth. But we know that some of the materials that we have on a robot are rated for certain depths, I think 300 feet. But the thing is, we haven't tested those pieces. The pool that we compete in at our competition is, I want to say like 30 feet deep. I might be wrong there, but there's something very interesting in that question, because when you're designing a robot that would be used in the ocean, you would want to be more considerate about the materials that you're using, because although, can I point here? Although like this tube here, which is what this whole piece we call a hull, inside will be housed the electrical pieces, and the hull is just an acrylic tube that protects the electrical components from the water. This piece is rated or has been tested at a much deeper depth than some of these like 3D printed pieces. So everything that is like this blue color and this red color on both of these robots are 3D printed. And so some of those pieces might break off before anything else major breaks. So that's something that is actually, something that's a very important factor to consider when you're designing robots for harsh elements.
So the next question is, when you were building this, did you think what you're doing at Desert Wave is going to help the future of humanity, or did you mainly build it for the competition?
That's a great question. Okay, I'll go with that one. So our team focuses on the competition, but we're able to use this competition as a way to enable a really great opportunity for undergraduate students to explore these really complex systems. And so a lot of us, when we first started the team, were freshmen or didn't have any experience within robotics. And so even though we joined this team and the competition is something that existed, and the purpose of us building this robot was for this competition, it really has helped our students to learn about the types of systems that are out there, the different challenges of working within different domains of robotics, so underwater versus working with like ground rovers. So I guess in short, to answer your question, our robots are designed specific to this competition, but the research expands much farther beyond that.
And this is a question from one of the Science Olympiad coaches. What types of degrees are the students on Desert Wave pursuing? I know I think you both mentioned software engineering and engineering robotics, but what are the other team members' majors as well?
Would you like to take this one, Sky?
Yeah, I can take this one. So we have many different degrees currently right now. So obviously we have robotics and software. We have mechanical engineering, we have human systems, we have electrical. And for us personally, it doesn't really matter if they have an engineering degree. It's just if they have the passion to want to create robots and it's something that they really want to do, anyone is welcome to join our club if they have that, that passion and that interest.
And this question kind of ties to it. What advice do you have for students who are looking to do something like this in college?
Yeah, well, my advice, okay. My advice would be to look for like extracurricular programs. So, you know, in high school, you have different clubs and like sports teams. Well, at college, there's an even more a wider range of opportunities for you, because there's so many different people coming from different backgrounds that have different interests. And so the university, well, at least our university, from what I can give you my experience, makes it quite easy for a small group of students to create an organization. So if you have a project that you're passionate about, you could definitely use like the resources that you have at your university or the community college that you go to help you enable like that build or that process of research. But there may already be a team that exists that could benefit from your participation. So like when I came into university, I transferred from a community college and we didn't have as many opportunities as we do here at Arizona State. So when I first got here, I knew that I wanted to know what I wanted to do with my degree. And so I looked around campus and all the other resources that the university provides to see what kind of projects I could get into. And it's really awesome. We have a lot of great like robotics programs here at ASU, but this team had just started, like they were a semester new. So that's the really great thing. If you have a project that you're passionate about, you could definitely use the resources available to you to make that an opportunity for yourself, but also to other students who may share the same interests as you. But I would definitely, like, if it's, go out of your comfort zone and reach out to other students and even your professors, because your professors would be a great resource for the kind of opportunities that are there at the university. That's my advice.
Skyland, do you have any advice for them?
Yeah, so I actually got introduced to this by one of my professors. His name is Adam Carberry. He was one of my engineering project classes. And he knows what I want to do for a career, which is build robotic prosthetics. And so he just showed me a couple of options. And what really drew me to this club is that I didn't have to interview and I didn't have to be like, here's my resume. They were automatically open. It didn't matter what skills I had. They wanted that interest. And so that's what really drew me to this club. And I've kind of been hooked ever since.
Awesome. So there's some questions about the structure design of the robots. This first one asks, how much does it cost approximately to make one robot? And maybe you could talk about some of the tools or facilities maybe that you've used on campus to print some like 3D printing and things like that.
Yeah, that's a great question. It depends on the specifications you're trying to reach. Now, this robot is quite expensive, but what really helps us with bringing the cost of this robot down is using processes like additive manufacturing or subtractive manufacturing, which are like 3D printing or like using mills to take away pieces of the frame. So something that we do and is very important within the engineering design process is that before you build, you try to create a prototype or you use computer-aided programs to help you create like scale models of the things that you'd like to produce. And so if we can plan to the best of our ability what we would like our robot to look like, as you can see on this computer program here, we then can take the material and use different machines that were available to us, like to like use a CNC router. So actually this frame is the frame for Dragon, and one of our new students was able to like go down to the innovation hub on the Polytechnic campus, which is like really awesome, like lab space filled with all of the, I don't know, all of the great tools that you could think of and ones that I hadn't even heard of before, and be trained on how to use them. And so this student here, she was able to go down to the Polytechnic campus, use this like incredible machine to essentially cut away the pieces from this material to create the design that she had loaded in. So, and we do similar things like that with all of these 3D printed pieces. Like we design it, and then we're able to use some of the machines to manufacture these pieces, so that, you know, we aren't having to like order them from third-party companies. And to design some of these pieces in metal like would change the rate of the robot, but also bring up the cost quite a lot. So because we have access to 3D printers, we're able to use a material that's a bit more forgiving for students who are still in the learning process. And so if we have to print this entire mechanism, or even just a small piece on this mechanism, it's not going to cost as much as it would to have to order it from someone who can manufacture it for us. So yeah, and I think that really doesn't answer your question on like how much some of these pieces cost, but I'll give you an example. So this like Subsonus like hydrophone array, these are hydrophones. It's what the robot uses to hear and communicate through signals under the water. Well, a unit like this from a company can cost quite a lot. Like I don't know, I think this is 17,000, and maybe Dr. Frank, you can correct me here, but it's something that we were able to, we were very fortunate in having it donated to us. And so that helps with the cost. However, using hydrophones isn't something that is brand new to this year. There's lots of research out there and tutorials and other resources that other people have used and documented from when they went through the experience of researching how to create a hydrophone per se. So a robot like this for us is quite expensive, and we have 2 of them now, and we've been very successful with all of, you know, all of this like the really awesome like sensors that we have access to. However, that doesn't mean that just because you don't have like, I don't know, the money or the sponsorship to be able to afford some of these pieces, you can create them, or you could try to create them yourselves, or something like this thruster. This thruster, like off the shelf, like if you were to buy it from like a company, could be a couple $100s, but if you were to reverse engineer it and like print some of these pieces yourself, then it would bring down the cost quite a bit. So
I think just to add on to that, the entire cost of Phoenix was about $40,000. So it's like a couple cars, or like one really nice car, which is kind of scary to think about it that way. But the cool thing about Phoenix is that a lot of, like Andre was saying, a lot of these sensors, especially the very expensive ones, were donated from another team that wasn't competing anymore. And so that's actually where the name Phoenix came from, is the fact that this was an older submarine that a team competed with. And then from those sensors, we designed a brand new one to compete in its place. So a lot, and then we also, you know, because of our success, you know, getting, you know, third place in the international competition our first time, we were able to leverage that and go to some of these companies and say, hey, wouldn't you love to be a sponsor for Desert Wave? And so we were able to get some additional sensors for the new robot by making sponsorships with these other companies.
I think that's something that you'll see is really special about ASU, as the students that we have are so passionate about these things, and their faculty, and they're really helping them do these amazing things that you might not see somewhere else, like a $40,000 robot. That's pretty crazy. But our undergraduate students are getting these experiences, and they're things that you can do as well. And so I think that's really inspiring how in depth and how they're creating this on their own. So it's just super inspiring. I think Dr. Frank answered a couple of these questions in here about the propulsion source, as well as If it broke, would it float or sink? So if you can see those in there. But there is a question about how much power is needed to run the robot, what types of batteries are used, how long does it run? How does that work?
I can answer that question. So we use like lithium batteries. They're from a company called Robotics. They actually sit like right here in, actually we don't have batteries on here. Wow, it's a power source. But they're these batteries that sit inside of these like what we call battery pods, or like these acrylic tubes. Maybe you can see it better here. But let's see, they're 12 volt. I don't know, Dr. Frank, could you clarify that?
Yeah, I think they might be 16 volt. They're lithium polymer. And as far as like how long they'll run for, it depends what the robot's doing. So sometimes the robot, when they're testing, will just be sitting in the water staring at things, and they'll be collecting data from the cameras. And so it won't really use a lot of power. And then sometimes the submarine's driving all over the pool and going fast and doing turns and going up and down. If it's like really active, where it's like driving around the pool, you know, probably about 20, 30 minutes. And then we'll have to start to pull it in to change out the batteries. But if we're just like kind of testing and it's just kind of sitting there for a while, usually, I don't know, 2 or 3 hours, it's usually good for.
And there's another question that's kind of asking, do you plan on using this vehicle, or could this robot or something similar be used to solve real world problems, and what type of applications could this have?
Yeah, so I can go ahead and answer that. So just like what we were talking for what AUVs are used for, this is the kind of thing that we're researching, and the thing that needs to start developing further so we can explore the ocean more. So like we said, it's only 5% that we've actually discovered in our ocean today. So when you work with the AUVs, we're trying to improve, like the PowerPoint says, search and rescue, mapping the seafloor, underwater inspections. And I was in the military. A lot of naval divers actually use this or use something like it. So it's very important for us, not only for civilian life, but for military life, for those discoveries, as well as for protection.
Awesome. Do we have, if anybody else wants to add any other questions, there's a comment in here that this is so cool, and it is so cool. We're always so impressed with everything that our students are doing. And while we see if there's any more questions that are coming in, I didn't know, ladies, if you wanted to give any advice. So all these students have their competition coming up this weekend. And so as a competition team, do you have any advice for them as they're getting ready to compete in the National Science Olympiad?
Yeah. First of all, congratulations to all of you who've made it to this place. Actually, us as a group, we're looking through some of the tasks that you guys are, like some of the competitions that you guys are going to be competing in and participating in. And we just thought it was just so cool. And so it's really awesome that you guys are taking advantage of the opportunities that you have. And my advice for you would just to be, have as much fun as you possibly can. I think as far as like working with a team, like communication is always very important. But you know, years from now, when you're in college doing amazing things, you'll have the experiences to pull from your memories in high school, and you'll never know like who you'll connect with. So it's just, I think that it's really important. I mean, obviously do your best, and no matter the outcomes, if you know that you did your best, then you've succeeded, no matter the outcomes of your guys' competitions. But if you have fun, like that's something that you will carry through with you into college and farther when you're sharing these stories in your own presentations in the future. So that's my advice.
And then, so I didn't get a lot of these opportunities that you guys are getting in middle school and high school. My school didn't have higher than a calculus class. We didn't have physics. We had nothing for engineering. So my advice is probably do as much as you can, have fun. A lot of these opportunities are just going to help you excel in college. And that hands-on experience is what you want, because you can learn math, you can learn science, you can learn it all. But until you do hands-on experience, you're not really going to understand what you're learning. And that's my personal preference.
Awesome. We have a question. Oh, sorry. Dan, do you have advice? Oh, go for it, Dr. Frank.
Oh, yeah. Skyland, did you ever have an opportunity to do anything like they're doing with the Science Olympiad when you were in high school?
No, the most that we ever got was a math competition, maybe how much science we knew. But as far as anything that you guys are doing, I've never had that opportunity. I graduated in 2011, so that wasn't really open for me personally. So that's definitely the reason why I'm saying just go out, do as much as you can, because this experience will help you throughout college. I didn't, because those opportunities weren't available for me, I didn't know that I liked engineering until I went into the military, and I worked on diesel engines and gas turbines with a ship, and that's when I fell in love with it. So definitely take all the opportunities you can in middle school and high school.
And just adding to that, like Skyland, you didn't have these opportunities. Andrea, I don't think you had opportunities like that in high school. I know that I didn't. So if you think this is like what they're working on is cool, imagine the stuff that you're going to be able to do when you're in college, right? Because you're going to have all that additional experience. Like when I went to engineering, I knew nothing about engineering when I started like my freshman year in college. And you guys are already going to have, you know, that baseline of all these really cool projects that you're working on in high school. So you guys are going to be rock stars by the time you get to college, and you're going to do amazing things. And then even beyond, once you graduate college, you know, you're going to go into industry, or you're going to go into academia, or wherever you want to go. You're going to do really awesome stuff. So we're really excited for you guys to see what you come up with.
So there's a couple comments in here about thanking you guys and how your work is so inspiring. And they're so glad your club also focuses on service and mentoring. And maybe you can just wrap up. There's a question about what you're going to do next. What's your next competition? What does it look like for you for the next year, and what you guys are looking to do?
Yeah, well, this is our third year in the competition. It's virtual right now, given the pandemic, and it was virtual last year. But my first year, we placed third in the world overall for our first year. And in our second year, we placed second in the world. And so we are just really gunning for that first placed position. So for the team, that is something that we are still continuing to do. We are still continuing to find opportunities in which we can grow. The competition is year round, but we work every day as a team to help our project reach its goals, but also each one of us. So, and outside of the project, we did say earlier in the presentation that we are more than just a robotics team. We are role models for our community, and that's something that I take personally, very personally, but it's also within our team motto that we are here to act as role models, but to give back to our community in any way that we can. And so spreading the ideas of how exciting it is to be in STEM to younger people, and show you people like you guys who's here at our presentation, what kind of opportunities are ahead of you. So I know that our team is not going to lose momentum on all areas that we focus on, both in our technical mission and our social mission. We just hope to continue providing opportunities for our members and serve as an inspiration for those around us.
And so we and Dr. Frank, they've dropped some things into the chat for you. There's an email address where if you're interested in connecting with Desert Wave, their email address is in there. We are desertwave@gmail.com. The link that they mentioned in their presentation for the game, that is also in the chat, as well as their website. I dropped that in there for you as well if you just wanted to see the types of things that they're doing. Our students and our faculty are always so awesome in helping us and doing outreach with us. And so we're very grateful that they were able to take their time this afternoon to present to you. And again, this was recorded, so we'll share it out. If you have other questions about ASU, I know that we have some information spread throughout your STEM Expo, but Mike also dropped his email into the chat as well. We hope that this information that was provided today was helpful to you and inspiring to you. We're so proud of our students. We can't help not share about them and share their stories and brag about them all the time. So if you ever need any information about any of the cool stuff that our students are doing, feel free to reach out. And with that, I would just say congratulations. We hope that your competition goes well this weekend, and thank you for letting us participate in Science Olympiad this year with you. So we hope you have a great night, and thank you again, everybody. And thank you to Desert Wave. You guys are so awesome. So we're so appreciative of your help.
Thank you for having us.
Yes, thank you.
Good luck to everybody, and thank you, Desert Wave.
Our pleasure. Have a great night.
All right, we're gonna